Hello and welcome, folks. Today we're doing something a little different. I have been made aware of something called picoCTF. So CTF stands for capture the flag. So this is kind of like like if you want to become a pen tester. Not that that's what I want to be doing, but it's something that is very interesting. And so it's free to sign up, and you're just given a bunch of hacking challenges basically. And so I wanted to go through that today and kind of show you my thought process, and we'll see what happens. I don't know. I've done a few of these already, so I have a little bit of practice. I can show you the platform. All you do is log in. All right, there. So I logged in, and I see a few options. So I'm going to hide the ones that I've already solved. And you can also open up your web shell over here on the right upper corner. If you click that, basically, and I'm going to expand it to another window here. You can log in, and this is like a shell where you have your own, basically like a remote environment, basically. So I'm going to sign in using my login for picoCTF and my password, Control-Shift-V, and it doesn't show you because it's hidden, but you can press enter. And I have logged in, pasting my password. So here I'm basically in a shell here. I can do ls-al, and you can see some of the stuff I've been working on. But for the most part, if the first time you log in, you'll have nothing basically going on. I think it's a Linux distribution. Nothing too crazy. Okay, so let's try tackling one of these. Let's tackle easy peasy. Maybe that'll be easy enough. So the description says a one-time pad is unbreakable, but you can manage to can you manage to recover the flag? Wrap it with picoCTF. So in the standard format is that you copy and paste the flag here, and it will have this form. It'll say picoCTF with curly brackets, and then there's going to be some number or letters or whatever in the middle of that. Okay, so here we have two things. We have this NC for NCAT, and that's making a connection to some server and on some port. And so basically we can kind of copy that, and I'm going to paste that in my shell here. Let me clear that, paste it, and basically I've made a connection to another server, and whatever the server spits out is what we're seeing. And so we see here, it says, welcome to our OTP implementation. I don't know what OTP stands for. So OTP definition. OTP, one true pair or pairing, one-time password. Oh, okay. So this is an encrypted flag, and here's a big jumble here. And you see I double-clicked it, it automatically copies because picoCTF knows what's up. What data would you like to encrypt? Okay, so I think what they're trying to show us is that we can encrypt something and kind of try out what we're looking for. And so, for example, I'll put a bunch of A's here and see. Here you go. That's what that is, encrypted. And we can try again, it looks like. So what's happening is that on the back end, it's like encrypting it and spitting out this stuff. Let's see what this other thing is. It's called OTP.py. So if I actually clicked on this right now, it would like open up a window and then download it to my computer. Actually, I don't really want that. I don't want it on my physical computer. I want to install that or download it in my instance here. So I'm actually going to close out by pressing Control-C to break out of that. So I'm now back in my shell here. So I can do ls-al, and that's where I am. So what I want to do is I want to take the URL here. So I'm just going to right click and say copy link address. And then I'm going to go here, and then we're going to do wget, which is how you would in Linux download things. So normally in Windows, you can just like go to a website and like click download, and that's how you get files on your computer. In Linux, everything's through the command line. So wget is a command that downloads from the URL that I said here, and I'm going to press enter. And it says, connecting to the site, and it downloaded everything. And now I have this OTP.py.1 saved. Oh, I think .1 means I already had something here. Oh, interesting. Okay, I think maybe I explored this one already, but I didn't actually complete it because I didn't didn't have the time. So let's cat OTP.py and see what that looks like. Okay, so it looks like a big file here. It looks like it's a Python file, so that makes sense. Import OS path. Key file is called key. Key length is 50,000, and it's just doing a bunch of stuff in here. So what I want to do here is actually, I'm just going to take this whole thing. Please take all this, and well, I guess this one technically is also part of that. I'm going to copy that. I'm going to open up my editor here. So I'm in VS Code as a text editor, and I just copied and pasted some code in the Python code, just so I can kind of see what's going on and make sense of it. Okay, so it looks like this is okay. So this is basically, I think, the file that's running on the back end here. So if I go back, you can see that this is the exact same file here, and I think this is so this this connection here. I think it's just running this file. So that's the idea. Let's look at the hint. It says maybe there's a way to make this a 2x pad. Okay, what is a 2x pad? I don't know. Let's find out. Let me clear this and go back to my VS Code here and kind of see what is going on. So first, so when we start this code, it says startup 0 that equals C. All right, so let's see what startup. What is the startup? Go to the function definition. Startup n is a key location. And it says open file flag being flag, and you read it. So there is a file called flag on the server that I guess we don't have access to, and that is being read in as flag. So that's going to be some text file, I'm sure. So this is the thing that we want to get, basically. We want the flag. And so another file is being opened called key file, and that's what this is, named key. So there's a file named key, and it has read binary. So it's a binary file that's being read in as the variable kf. So that's also going to be some string, but it's a binary string, whatever. Key location is start. So we know this is coming in at 0, and then stop is 0 plus the length of the flag. So whatever the length of the flag is there. So it starts off at 0, and then you're adding whatever the length of the flag is. So flag length is the length of whatever the string is from that. Okay. The key is whatever was in the file, the binary file, with a start and stop. So in Python, this is going to section something off. So it's going to section 0 or at the start and whatever the stop is. So there's going to be, it's like cutting out part of this key. Key location is now set to the stop location, or the stop. Okay. Results. And this is your encryption. Okay, so basically what's going on here is what is effectively what the encryption is. So we need to make sense of this, and if we can, then we can kind of tease out what the heck is going on with the encryption process. So we have, so it's converting this to a list. So let me kind of break this out a little bit by itself. So we have here a list. You're converting them, so it's a mapping. You're mapping what? Lambda p and k. You're creating a string that is, I don't know what that is doing. Let's double check what that is. All right, so I have Python here. Let's bring in that string, and I'm not quite sure what that does. So 02x dot format, and then order is a way of taking a string, I think, or a number. What does order do? Or it takes a number, I think, and converts it. No, it needs to be a string. So it takes a string and converts it to a number, and then within this format, it's taking the k and doing a binary XOR operation on a number. Okay, that's the encryption, and then that's what this string is doing. Mapping takes the flag and the key. So I think it takes iterables. So what does map do? Let's say P is a string that is A, B, C, D. K, which I believe K is supposed to be, K is, oh no, the key. Oh, the key is this, which is the same length as the flag, basically. So the flag and the key are the same length. So these two things are the same length necessarily. The flag and the key are two strings. So let's say WXYZ. So these two things are the same length. I have to do a mapping of lambda, let's say PK. I'm going to try and copy this. I'm not going to do too much with it though. I'm just going to say P plus K. And then put in the, oh, I'm using the wrong name really, huh? Let's call this flag equals P. And then key equals K. So that we're now dealing with flag and key. Okay, so anyway, map lambda. So it needs to apply function pk, and I'm going to say p plus k, which is going to concatenate them, flag, and this is going to give you a map object, so I need to convert that to a list, which will give, so we can actually see it human style. We see here that it's basically, you know, it's going to loop through the flag and the key, each element one at a time. So this flag thing is a string, which isn't iterable, and it's going to go through each one, and they're both the same length. So we're seeing the A plus, you know, A and W. So what they're doing here then is that their mapping is basically, instead of the P plus K, it's now going to be ORed P. Oh, interesting. Because the key is not a number, right? You can't do ORed P and then K here, because I think that'll, yeah, because it's a string. That means the key is a number. Okay. So if you have a file of numbers, I'm curious. So let's make a file real quick here. So I'm going to just create one here called key, and another one called flag, because, you know, we can wait with that flag here. Let's say our flag is all A's. Let's give it 5 A's. Say that the key is going to be numbers. Let's call it all ones. All right. So we actually do have a key and a flag file that will allow this to run, and we know what they are, so that's nice. I'm curious though, like if you read in I guess this is a binary. How do you know that though? So let's say open key RB read binary dot read. The binary thing, as it should be, it's a binary string, so that's what's going to come in as this. But if I do indexing on it like 0, 4, so how can I do bit operation on that? I'm also recognizing that I can like put in like 1,000,000 here for the key location, or that's what it's, no, I don't control what gets put here, right? It encrypts. What does encrypt do? Input, what would you like? It strips it. User input. If the length is 0, return -1. So or if the length is greater than the key length. Okay, that's interesting. So you can actually like kind of tease out what the key length is. So I can, okay. Oh, actually this is key length. Okay, never mind. 50,000. Okay. Start up is the length of that. It reads in the file, the key file. If the stop is greater than the key length, then you modulus it, and then you take the start plus the stop. Else you take the start and stop. And this is the same logic, I think, as above. So it's the same function effectively. Because here you go, there you go. Returning key location. But it seems like you're returning like this key location then. So this C is the new key location. And this thing here is like wrapping it. If you go beyond the key, like if you go too far, then it like wraps around basically. I actually want to run this p.py. That one I haven't had to do. Sure. Okay. What data would I like to encrypt? Oh, by the way, it ran no problem. Right? Like this startup didn't change anything. Open key RB dot read. Did that no problem? Am I freaking out about something like that I shouldn't be? Key. Wait a second. When you index a binary string, it will give you a number? What? I did not know that. Is that a thing? Hold on a second. 111. Right? Okay, so let's X. X equals this binary string. X 0. 49. If I do ORed of 1, the string 1. Oh, what the heck? Are you serious? Because it's a binary thing? Is that how that works? I did not know that. Okay, so interestingly, this code does not break because binary strings, when you index them in Python, it will spit out the ASCII number. So this does not break. So I think my key is a little weird. So let's do 1111. Okay, cool. All right. So now that that makes sense, this function does work, and what it's doing, it's taking the each flag character, it's just getting the ASCII, and then it's doing this XOR with the character that's in the key, which doesn't have to be a number either. It could be letters and numbers. So interesting for one. And then what's this formatting doing? Okay, so let's check that out. You can also specify formatting symbols. Only change is using colon instead of the percentage sign. X, hexadecimal with lowercase letters after 9. Okay, there we go. You can use a string formatter for this purpose. Does anyone know how to get a character to hex conversion where the output is always 2 digits? And you do that by doing this. Okay. So, like number 1, number 2, number 10, because it's hexadecimal, that's what it's converting it as. So it's taking, so it's going to be in a hexadecimal format, specifically limited to 2. You map that out. Key and flag are, let's say the flag is 1, 2, 3, 4, 5 A's. The key is binary with 1, 2, 3, 4, 5 ones. You get a map object that we need to convert to lists. I remember that. Yeah, okay. We get 50, 50, 50. And in the end, that will be joined, and that is how that's going to work. So we're going to just do like, take this, call it X, say this join X, and we're going to get 50, 50, 50, right? Okay, so if that is my key and this is my flag, then when I execute the code, I'm making another 4th window here. I'm going to run Python otp.py. Python needs to be spelled properly. And we see that this is the encrypted flag. So we get the 50s right there. So that's what it's supposed to look like. I don't know if if it's always going to be 2, because we just saw that you can technically go over that limit of length 2. That's not great, but let's see what we can do with that. All right, so we can unencrypt it though effectively, because we could just take the number. So we'll get the number like 50. I think if you know just 1, because what you know is the result, right? And it's XOR, so as long as you do XOR back, it'll be okay. So you just need to know 1, the flag or the key to do it. We don't know the flag, obviously, so we're gonna need to find the key. If there's anything we can do to find the key, we can reverse this process and get the flag. So what does that look like? So that would be something like, so the number 50 as a string. Let's say that so actually we know this stuff, right? So if we look at ord A, that's 97. And if we so if we look at the binary string 1, and then we index on it, that's 49, right? And so if you do 97 XOR 49, you get 80, which is not what we're looking for. Fantastic. What did I do wrong? But it's not 80 though, because it's like the formatting of this whole hexadecimal thing. So do X format 80. That's what gets you the 50, right? Okay. So the 50 needs to be, we need to undo the hexing. How the heck do you undo that? I don't know. I don't know if you can. I'm sure you can actually. So that's the point. So how do you unhex? Int convert hex to int Python. Really? You can just do int on that? What? No. Right. Okay. Duh. That doesn't make sense. You have to provide a number here, so it's int 50 16. Oh, okay. Okay. Interesting. So, if a hexadecimal string is not prefixed, then specify the base value, because hexadecimal is in base 16. That's why. Okay. That's cool. So we can undo that process. So so each one of these of length 2, we can do this to it, get the number, which is like 80, and then go through this process of doing XOR as long as we know one of these values, like the key probably, because the flag is what we're trying to discover, right? So the key's got to be found. So we need to find the darn key. So how can we find the key? Let's find out. I'm sure there's some logic here in this step. So after you start this file up, you have startup, which starts at 0, and then you have a while loop, and that's when it's basically asking you, hey, what do you like? What would you like to encrypt? And then you put in some value, and that's what it's doing. Okay, so we need to figure out some way of breaking this so that we can grab the key somehow. All right, so let's look at the logic here. So we put in our information, it gets stripped, and the length is assessed. If it's 0, you basically cancel everything out. Or if the length is greater than the key length, which we're establishing here as 50,000. So unless I type a length of 50,000, which is possible, then it's what we're doing here. That means that the key is of length 50,000. I don't know. All right, so start location is the last location. See here, that's what it was. So whatever that is what gets put in here as the new start the key location. Okay, so that adds a little bit of complication because then you need to know the length of what you were working with. Although I think we kind of do, because we know how large it was when we ran it the first time. From the web shell, it looks like my session has ended, so I need to log back in. I'm gonna go back to this thing and copy it, make my connection. All right, so this is the encryption. Copied it, and let's go back here. Let's see. So this is the encrypted string. What's the length of my encrypted string? It happens to be 64 in length. So we can just divide that by 2 and assume that's how many characters that the flag has. So, and maybe I'm missing that. Maybe I'm missing that wrong. 64 divided by 2. I can't do math. 32. I'm assuming that this is going to be 32. So I'm assuming the key location the first time is C. C equals 32. And now the key location is 32. That's our start, and our stop is plus the length of whatever the input is, which is less than 50,000, but for the most part, I get to determine that. So that's what our stop is. We read in the key file again, so we have our key information, and it says if stop is greater than or equal to the key length, then do this. Otherwise, do this. So I'm assuming there's some jankiness happening here. So let's see what happens here. So stop modulus key length. So you will get something that is less than 50,000. Okay, and then you take your key data, the binary, and you grab this from the start, which is 32 onwards. So you don't actually have the key information that is part of the original here, because you're like starting from the previous stop location, but you are wrapping around because of this logic. So I think this is where we need to exploit this. So we can exploit to learn first 32 characters. How do I exploit this? So it says our stop is modulus, right? So we can take the start, which is 32, onward. So it's from the start to the end. What can I do to force this to wrap over nicely? That's not 50,000. But I guess you have to deal with that, right? Well, the actual key itself though may not be 50,000. So what happens? So if you have, let's say for example we have a key, or actually I think we have a key, right? The old key. Let's refresh that. And key equals that. Key is that, right? So if we have our key and we take, oh sorry, I mean KF, right? Take KF and we grab the 50,000th. It's still just going to give you the basically everything. So if we take the start from the start to the end, and our stop is very large, then we're basically concatenating the same thing twice. So the key is going to be just the key on top of itself, right next to each other. I'm counting on that though. So it's taking the UI, wherever I put in with the key, which I control, by the way. I can control that. So I can get at what the key is, and the link that I put in is going to determine that. Online string tools, thank you. This is what I'm talking about. Input string A. Repeat it 50,000 times. Copy to clipboard. I'm gonna go back. We're gonna paste our thing. Okay, it didn't like break up with different lines, and bam, we got something. So here you go, it says. We've got a bunch of stuff here, and I'm confident that this is basically the entire code for the key. So what we've done here is we've taken this key string, we've gone from the start, which is effectively like the last place that it started, which was like 32 characters in, and then so now we gotta basically take that and grab the last 32 characters from that. And by 32 I mean 64, because it's been converted to like the hex format. And we're gonna grab the last 64 characters. I think that will do it. So x equals that, length of x 65, so I need to grab the last other way. 65. Okay, perfect. I say, what is x now? X is that thing. So we know that we can break these things up here. These are in order. So this is the 32 in order from the key. And this is all matched with my input, which was all A's. So this hot mess here is when you do the XOR operation with a bunch of A's, which we know. But first we need to convert this via converts via the int. Remember, int, blah, blah, and then 16, right? So for each one of these, I should say 2. So we need to break these up into 2, right? Length x, 64. And then we start with 0 to the length. And then we skip 2. And so this is going to be I, really. And then we're going to say, I want x of I up to I plus 1. That's not what I meant to do. Oh my goodness. Plus 2, I think, probably. Okay, so what does this give us? The 90, which is here, the 05, which is there, 53. Okay, so this gives us the list that I'm thinking about. Great. So this is the cut up. So cut up, that's what we get. And now we need to do the reverse stuff of this. So we need to do int 60 on this. So I'll do a mapping. Should I do a map? Whatever, it doesn't. I think list comprehension is pretty intuitive. And I need to do the XOR on that using A. So what is A again? Ord A is 97. So we can do list comprehension. I like that. For val in cut up, we're going to take the val. We're going to do int on that val, 16, and then we're going to do XOR with 97 because we know that's the value here. And we get this hunk of junk, and that hunk of junk is the value, the indexed value of a binary string. So we need to convert that back to a character. So that's car, I think, or CR, I think, CHR. I think that's how that works. Holy moly, we got it, folks. Or I think we got it. You know, that's what I hope. This looks a little weird here, this x14, but technically that is a valid string. That makes me a little uncomfortable because that is more than one, length character. Okay, let's do this. X14. If I do index 1 on you, you're 20. Okay, interesting. But can I do x1 out of range? So this is one character. That's interesting. So if I do like this, is that scanning literal? Oh, because it's an escaped character, of course. So x14 represents something. Oh, so it is a single character. It's been escaped though. Interesting. Okay, so that's a valid. This is all valid then. So this is the first 32 characters of our key. I now have this. So this whole thing here that I just made. Oops, let me like go back up here. So this thing, right? So that I can do a whole join on and grab that because this whole thing is our key. Now replace that, save that. It's being it's considered a binary, and now the flag, which is unknown at this point, we can reverse that process by doing kind of the same thing that we just did. But what did I just copy? I just missed copying something. Oh yeah, this whole thing. Copy. Thank you. Okay, so that is the flag. So that is the no, that's not the flag. That's like the result from that. So that's what this is. Okay. So we just do kind of the same thing. We take this string, which I'm going to call W for no good reason. I'm going to apply the same logic as I did before. I'm just going to kind of go through my history and cut it up basically. So instead of length of that, it's length of W. This is W there. I'm going to call this W cut up. So W cut up, which I'm not spelling properly. It looks like that. And those are hexadecimals, so we need to convert them back. Except now we can say W cut up, the val in W cut up in right. Okay, so let me stop myself for a second. So we need to actually pair and join and basically like map this thing. So length of that of W cut up is 32, as it should be. And we need to actually import this key and read the key in. I can just keep it in its like raw form. Like, why do I need to put it into a file, right? Just this thing right here. Okay, I'll just copy it as is then. This is the key, deduced key. All right, so that's my deduced key. It is of length 32. Everything's 32, hopefully. So now we just need to pair them up. The W cut up, which is the text string format of my encrypted flag. And then I have my keys, which the key, same length, that can be used to do the XOR operation. Is it in the right format, though? It's not the binary one, but it should be fine, I think, because they're still numbers, right? Deduced. Those are not numbers. Is I don't need to convert these to characters because they are just straight up integers, so I don't need to convert them. So we can keep them as just the raw number because we're going to use that anyway, so that's fine. Okay, so we have the raw number. We need to map those with the 32 other things, and we can just do a list, I guess. Yeah, a list of map of lambda of X and Y because I'm so original. And I'm going to take X and do XOR with Y. That's kind of it. And we're going to put in the W cut up with the deduced key and unsupported string int. Who's a string? W cut up a string? Wait, what? W cut up. Oh, you are strings. Oh, duh, because I need to convert you to int. Obviously. Okay. So W cut up, which is X, is going to be needed to do int on that with 16, then modulus. And so those are our numbers. We need to take those. I'm going to store them first. So this is the results, and then I'm going to join eventually of the results, or are in results. No, this is all messy. It's all very messy. We're going to convert it back to character, CHR. And that does not make any freaking sense to me. Fantastic. Well, I mean, I'll give it a try, but I don't think that's it. I think I messed something up along the way and wasted a whole lot of time. So that's great. That's just great. Flag is incorrect. All right, I am looking at this write-up, and holy crap, I am just not very familiar with this landscape of doing things in capture the flag land. But basically, and it's very clever. You can pipe things, of course. So me like hard coding 50,000 A's doesn't need to be done. I can just activate Python, have it print out some stuff, and then pipe that into the call to the site, to the server. So that's really clever. So what they're doing here is, and what it's very clear too, it's very clever too, that I was doing XOR with like the letter A because I just was picking A. Why am I doing that? Pick 0. Like you're doing XOR on 0, it means it doesn't change the thing that you're XORing on. So instead of doing that, I should XOR 0, which is what that is. So basically make a bunch of strings, 50,000 length string with just 0, hexadecimal 0. That would be that works, but what was clever here is that they're using this like positioning to just make life a little easier, because 50,000 is the limit. So you make 50,000 minus 32. What that does is that it positions your start and stop in such a way that the next time you call it with 32 length XOR of zeros, you just get just the raw key XOR basically. So that is what I should have done. This is the key that you would have gotten. So let's do that right now. I have not tried it yet. I should have thought about this already, but let's go into the shell here. Let's make the, actually I don't want to make the call here. I actually want to try and do this whole piping thing. I'm not sure about what this, I've never tried this before. This like -C. So what is that? Python -C. Oh, the command. Oh, you can execute command directly. Okay, so let me balloon this out a little bit more. Let's exit this, put it out. So we have, if I do Python -C, that means execute this command like print. Yo, I'll use double bracket because I'm using single bracket there. And that's what it does. Okay, so you can pipe that output into something else. That makes sense. And you're piping that into the call to the server. So I'm actually going to copy this, but I know what's going on at least. And what's happening is they're printing 50,000 minus 32. So whatever that number is, I can't do math. Zeros, basically hexadecimal zeros. And then clicking end, new line, which will trigger the next call to the server, which is the next I go back here. Basically it's like this next, like saying, hey, go to the next step, and then it's calling it again with a bunch of zeros, but this time it's only 32 zeros because that's like the end. You're wrapping around to the other side. So I'm going to copy this because it makes sense to me now, and I'm going to do that on the shell here. I don't think I need Python 3, and I think I do want this here. Copy that there, and perfect. So I got a whole bunch of junk, which doesn't matter, which is the tail end of the key. And now here is the XORed key, but it would be encrypted, but because I'm hitting it with only 0, it's like it doesn't matter because you're XORing on 0, so you're getting the raw key. So this is the encrypted key, so I copied that. So it's encrypted. Actually, it's not encrypted because I did XOR on 0, so this is the actual key. So that's what that is. And now that I have that, I can take the key, the flag, which I also have, and go back to the site here, and this whole thing was the flag. So this is the flag. Same length, you'll notice, and I just need to do I need to XOR these together, I think. This is the encrypted flag. Encrypted flag is that. And so I can break it up 2 at a time, just like I did before, and then do the XOR on them together. So I will do that now. So P equals P is range 0, 32. I'll say int in both of these. They're still, I think these are still in hex because they've been formatted as a string to be that. So I need to get the x I plus 2, convert it to 16, XORed on to basically the same thing, but now with the key I plus 2. Develop syntax, great, for I in range. Oh, I see. Oh, okay, I see. So it's this. It needs to be not a comma. It needs to be a colon, obviously. Very good. And then these need to be converted. Let me just save this as W for a second, and then I can do dot join, and I can do mapping on that. Actually, I can do list and map lambda. X is car. I just do car. W. Is that a thing? I mean, I don't know what this word is, but okay, sure. Let's give it a try. That was the answer? The hell? That worked? What is that even saying? I don't know. Is that a word? I don't know. Anyway, holy moly, that was mildly frustrating, as I found many of these to be. This is something I'm kind of interested in, and just getting more familiarity with security, because I do write code that matters eventually. So I hope that it will make me better at thinking about security, and also just like being more of a hacker and thinking about how to get around some of the issues that I tend to find myself getting into. Anyway, folks, I hope this has been useful. If this is the kind of content you like, please make sure to like, subscribe, and do all the good things, and I will see you next time. Take care.